Hello, my name is Professor Johnson, and today I will discuss probability with the multiplication rule and the addition rule. And we say the first rule, the multiplication rule, as probability of A given B, that's the vertical bar, given, it's a conditional probability, is equal to the probability of A intersect B. Intersection we will think of as an AND statement, so I'll think of this as AND, divided by the probability of just B. Now if we look at the addition rule, it says probability of A union B. Union we will treat as an OR statement, so it could be either or. So the probability of A union B is equal to probability of A plus probability of B minus the probability of A and B. That is our addition rule. The A and the B are just letters and they're placeholders. Really, we can use any letter that we can imagine to make this work. So let's pretend I could put probability of T given W equals probability of T and W divided by the probability of W. Every letter, right, is just a placeholder. So I've represented W here, okay? And then you could see T here, like just like the A and the A, right? It's just placeholders. So you can use any letter that you want. Sometimes in word problems, switching the letters will help keep things more organized. I can do the same thing with the addition rule. So the probability of, let's just say, X or Y, or X union Y, equals the probability of X plus the probability of Y minus the probability of X and intersection Y. Okay. As you can tell, I just followed the pattern. Put all the A's in. So X landed in the X spots for A, and Y lands in these spots for the B if you follow that pattern. Okay? So letters don't matter, they are placeholders. You could even use symbols like triangles, squares, circles, smiley faces, whatever you want. So let's go to an example on how to handle these formulas. So given the probability of T given R equals 0.18 and the probability of R equals 0.76, find the probability of T intersect R. So this is an AND statement that we're looking for. We're trying to find this. Now, let's think to our equations, and we have to narrow down to which one we can actually use, which rule is applicable. Okay, so AND. Which formulas have an AND in it? Okay, so you can see both of them really have the AND statement, but then we need to think about what else is given to us. The very first thing, we are given a conditional probability. Given a conditional probability, it looks like we can use the first one, but can we use the next one? Nope. And then we're given a single probability of an event, and that would match with the first one again. So it looks like we can eliminate using the addition rule. We are going to be working with the multiplication rule. And now, let's rewrite the probability to match the letters that we're given. So we have T given R, and if you follow the pattern, it would be probability of T and R divided by the probability of, instead of B, we are replacing the B with an R. Okay, now what we want to find this probability. Now, we know the values for the other two spots. So we know the given statement part, the conditional probability is 0.18. We do not know what I highlighted in yellow. That is what we are finding. And then we do know the probability of R. That is 0.76. How can we get just the probability? What you need to do is multiply by 0.76 to both sides. And when you multiply by 0.76 to both sides, on the right hand side you can see they cancel out. Okay, and then we would have on the left hand side 0.76 times 0.18. You can use your calculator and If you take a second to type it in, you should get 0.1368. And then I'll finish my notation off. This is T, the probability of T intersect R. And there we go. We are all done. So sometimes you have to manipulate and move and rearrange to find exactly what you're looking for. But the first step is to narrow down which formula you can actually use. Let's do this again in another problem. So let's look at what we know. Let the probability B equals 0.48. So we're given probability B. Let's just label that. Probability of A union B is also stated, A union B, but notice already the very first formula, our multiplication rule, does not have the OR statement with it. And then we have the AND statement. Okay, we have an AND statement in both of them. And then we're finding the probability of A. Which formula that's highlighted actually would work for us? Well, as you can see, that first one, the multiplication rule, doesn't have everything we need to solve what we're looking for. So I'm going to take just what I've highlighted. And actually, it's already written with the letters that we like. So I'm going to start replacing by direct substitution what these values are. Probability of A is what we're looking for. Plus, probability B is given 0.48 minus the AND statement, that would be 0.21, right? You can see that matches up. And then the OR statement would go on the left-hand side. That would be 0.7. Now, let's just think about what we know. Well, with order of operations, we don't have any parentheses or exponents, anything like that. So let's just deal with our addition and subtraction. Well, 0.48 and 0.21 could go together. So I'll just write probability of A. 0.48 minus 0.21 is positive 0.27. Now, we need to solve for the probability of A. In order to move the addition of 0.27 away, we need to use subtraction. So I'll subtract the 0.27. And then 0.7 minus 0.27, use your calculator, you should get 0.43. And this would be equal to probability of A. And then we would be all done. We've simplified fully. Let's do this in a word problem. Let's up the difficulty a little bit. So suppose the probability that a student owns a pet and has a sibling is 0.44. I'm going to highlight that special word and. Also, the probability that a student owns a pet given they have a sibling is 0.78. Notice that's another special word. What is the probability of having a sibling? Okay, round to 3 decimal places, P we'll use for the event of having a pet, and use S for the event of having a sibling. So let's write out what we know. We were given an AND statement. So we were given owns a pet and has a sibling is 0.44. That's the very first sentence. Let's go to the second sentence. Probability owns a pet, so we'll put P, given they have a sibling. Now the given is represented by the vertical bar. Our conditional probability is 0.78. Now we are looking for the probability of having a sibling. This is equal to something. That's what we're looking for. Now again, the letters don't matter, right? We need to figure out and narrow down which rule we will be using. On the left-hand side, we can see that we have a given statement. So we are going to be using the multiplication rule. So now let's use the pattern that we know. Probability of A given B. The given part would be 0.78. The AND part will go in the numerator as 0.44. And then the probability of S for sibling will go in the denominator. Now we need to get probability of S. We need to somehow solve for this To solve for it, we need to do some manipulating and moving around. Well, I am going to multiply both the left-hand side and the right-hand side by the probability of S. And if you do that, then the right-hand side, you can see probability of S divided by the probability of S would give you 1. So now my right-hand side is just 0.44. My left-hand side would be the probability of S multiplied by 0.78. So we're multiplying both of these values, but we just don't know one of the values. So to get probability of S equal to some value, we would have to divide away the 0.78, because right now it's multiplication. We need to divide to get rid of the multiplication. So we will simplify and get 0.44 divided by 0.78. This will give you 0.564 if you round. Let's go to one more word problem. Suppose the probability that a student can ride a bike is 0.85. The probability that a student can skateboard is 0.14. Lastly, the probability that a student can ride a bike or skateboard is 0.9. What is the probability that a student can ride a bike and skateboard? Notice we were given 1, 2, 3 things, and we're looking for a fourth thing. Knowing that, I can make a good guess that I'm going to be using the addition rule, but let's further investigate to make sure that we're using the addition rule. So let's use B for bike. So let's just say probability biking would be 0.85. Probability skateboard, let's use S for skateboard, 0.14. You see, this is the benefit of being able to pick letters and interchange however you want. And then the probability that the student can ride a bike or skateboard, okay, the or statement would be B union S. It looks like bus, but it's really B union S, right, for biking or skateboard. And then we were given that that's 0.90. And then what is the probability that a student can bike and skateboard? This is what we're looking for. And you can see we have probability of 2 individuals, and then we have the intersection that we're looking for and a union that we have, but we were not given any given statement, truly, right? So we will be using the addition rule. So let's make our own formula, since the letters are quite different in this one. B union S would be equal to probability of B plus probability of S minus the probability of B and S. And I'll separate that away. So the probability of B union S was 0.90. Probability of biking, 0.85. Probability of skateboard, 0.14. Minus probability of B intersect S. The probability of biking and skateboarding is what we're looking for. So 0.85 and 0.14. Let's put those together. That would become 0.99. On the left-hand side, we have 0.90. And then don't forget, we have the subtraction piece. So I'm going to subtract 0.99 because right now it truly is addition. I'm going to subtract it. And whatever I do to one side, I have to do to the other side. And if we simplify, 0.9 minus 0.99 will give you some value, and we'll have negative probability of biking and skateboarding right there. Now this would give us on the left hand side negative 0.09, and we have negative probability. So we have a negative equal to a negative. Really, I want to get rid of that negative, so I could divide both sides by -1, or you could multiply by -1. Either way, dividing by a negative makes everything positive. Negative over negative is positive, so 0.09 is equal to the probability of B and S. And we could stop right there. Thank you for watching my video.